Welcome to the continuation of organic chemistry. So far, we've looked at our introduction to organic chemistry. We also looked at alkanes, we looked at alkenes, we looked at alcohols. In the previous video, we looked at carboxylic acids and esters. In this video, we're going to take a look at polymers. So, to avoid the situation like the one we had with alkanes, where we had to discuss main concepts in 40 minutes, what I'm going to do is I'm going to deliver this subtopic into two videos, polymers. So this is going to be the first video. There will be another video. The idea is to have a few concepts in a short time, so that at least you can grasp the concepts to the core. So polymers are also called macromolecules. Polymers or macromolecules are just giant molecules formed by joining smaller units called monomers. If, for example, a house is a polymer, then the blocks that makes up the house are called or should represent monomers. So these polymers or macromolecules are produced by the process called polymerization. The definition for polymerization is it is the joining up of smaller units called monomers to form larger molecules called polymers. Next, we look at types of polymers or types of macromolecules. So there are basically types of macromolecules. The first ones are called synthetic or artificial macromolecules. The second one are called natural macromolecules. Synthetic or artificial macromolecules are those macromolecules like these ones, pipes, plastics. Actually, when you think of synthetic macromolecules, you should be thinking of plastics. So synthetic macromolecules are basically made by man or are man-made polymers. Well, natural macromolecules are those which are found in nature. So there are two types of synthetic macromolecules. The first ones are called additional macromolecules. The second ones are called condensation macromolecules. The classification or the difference comes from the process that are used to make them. Additional polymers are made by the addition reaction we discussed when we were talking about hydrocarbons. Then condensation polymers are made by another reaction called condensation. So before we can go into the details of these synthetic polymers, let's take a look at some advantages of synthetic polymers. What made people to start coming up with man-made polymers? First, they are durable. By that, it means they do not rust, they do not corrode or decay. So if you buy a plastic, you put it somewhere, after years you're going to find it there without rust, without corrosion, without any sort of decay. Second, they are lighter than steel, wood, or stone. If you look at your phone, the covers of your phone are made of these synthetic polymers. So these covers, they provide the needed strength so that even when your phone falls, the internal components are not going to be affected. But it is light. You can put it in your pocket. If it was made of steel or wood or stone, it could have been a different scenario. Third, they are thermal and electrical insulators, which basically means they are bad conductors of heat and electricity. Because of that, if you want to protect something against heat and electricity, you can use them. Also, they are used to insulate electrical cables so that they do not make what is called a short circuit, which can be disastrous. And they are not expensive. They are produced as byproducts of oil refining. Okay, meaning that for them to be produced, what actually happens is oil is when oil is about to be refined, there are some products which at first when the process was being created were deemed not to be wanted. And actually, when refining oil, the end goal is just to refine oil. But when that is happening, there are some waste that come out, and those are the ones that are used to make these synthetic polymers. Also, they are flexible in use. You buy a plastic for for carrying things, then you can use it also to insulate something, so they are flexible in use. Now, with all these advantages, what are the demerits or the disadvantages, the bad side of synthetic polymers? There are basically two disadvantages, all centered on the issue of pollution. They are pollutants. First, they are non-biodegradable. So the fact that they are non-biodegradable, the fact that they cannot be decomposed by bacteria, the result is the non-biodegradability makes the disposal of plastics difficult, and this results in pollution. So you throw a plastic here, it won't decay, you just find it there even after many years. Therefore, if you keep on throwing plastic, they'll be accumulating, therefore creating land pollution. Second, plastics burn easily and may produce poisonous gases on combustion, resulting in air pollution. So the non-biodegradable part, there's no way to deal with it. Inherently, like by nature, the way they are made, they cannot be decomposed by bacteria. There's nothing we can do about that. Well, this one for burning and producing poisonous gases, we can reduce their flammability. By that I mean we can add some chemicals so that they don't easily burn. So the mitigation measure for this second point, mitigation measure means what we can do to make sure that plastics don't burn. What can we do to make sure that plastics do not participate in burning? It can happen that maybe a house is on fire. Because of the nature of plastics, they can easily catch fire. So what can we do to reduce such instances where plastic are involved in burning and they end up emitting poisonous gases? So the mitigation measure is simple. They need to be coated with fire retardants to reduce the risk of fire. So fire retardants are just chemicals that makes plastics less flammable. So now we go to the ultimate solution to all the problems that plastics bring: recycling. So why should we recycle plastics? It's because of the two issues, the two disadvantages that I've highlighted. The first being they are difficult to dispose of. The second being when some plastics burn, they produce harmful gases. So instead of burning them and instead of throwing them away, why can't we keep on reusing, recycling? So now we go to the first type of synthetic polymers, which are called addition polymers, which I say that they are produced by the action of, by the process of addition reaction. So addition polymers are polymers formed from smaller identical unsaturated monomers. So in addition polymers, we're talking about alkenes participating in this reaction or in the formation. Alkenes are the unsaturated. And remember, alkenes are more reactive than alkanes. So alkenes, when maybe they are two, it's possible that they can connect to each other, they can react. Therefore, that's just an insight to make you remember that addition polymerization is for unsaturated monomers such as alkenes. Addition polymers are formed by the process called addition polymerization. So this is just an emphasis of the point that I had said. Now, another emphasis is no other product is formed apart from the polymer during the process. So the other type of reaction, condensation, there is a product that is formed. Well, in addition polymerization, there is no product that is formed. It's just monomers joining, no product formed. But in the condensation, as we are going to see in the next video, you're going to see that there will be a byproduct that's going to be formed in the polymerization process. So another point to note is in addition polymerization, the polymer is the same empirical formula as the monomer. What is the empirical formula? Empirical formula is the formula that shows the number of atoms, the number of each type of atom in a compound in its simplest form. So what I mean by that is, let's say we have this monomer CH2 and this polymer. So this CH2 has one carbon atom and two hydrogen atoms. So to express this in its empirical formula, we ask ourselves, is there a number that goes into 1 and 2? There is no number that goes into 1 and 2. Therefore, this is in its empirical formula. So by number, I mean other than 1, because 1, it can keep on going, nothing is going to change. What about this polymer here, 100 and 200? Yes, 100 goes both into 100 goes both into 100 and 200. So 100 into 100, it's 1. 100 into 200, it's 2. So this polymer, written or expressed in its empirical formula, becomes this, where 100 into 100, 1. So we have 1 here, which is invisible, and 100 into 200, it's 2. So as you can see, the empirical formula of the polymer is the same as the empirical formula for the monomer. So we're going to take a look at examples of addition polymers. We're going to discuss the repeating units or the monomers that makes up the addition polymer, and we're going to take a look at some of the uses of the given addition polymer. So the first one we're going to take a look at is called polyethene. Remember, poly means many, so polyethene means many ethene. So with that being said, polyethene is just formed by when ethene molecules combine. So this is how polyethene is formed. So I will go into just a bit to explain how the bonds break and how the bonds form. So we have ethene and ethene here. There are double bonds here. So remember, each carbon atom should be bonded to each carbon atom should have 4 bonds. So this carbon atom has 4, this carbon atom has 4, this carbon atom has 4, this carbon atom has 4. Remember, these are unsaturated, meaning that there is a chance that they can have some more atoms coming in. So this bond can be broken and this bond can be broken. When these bonds are broken, this carbon will need to form a bond with something, and this carbon is going to be in the same situation. The same with this carbon and the same with this carbon. So what they are going to do is this carbon will form a bond with this carbon, meaning that this is going to have 4 bonds and this is going to have 4 bonds when these bonds are broken. Then this carbon atom here is also going to form a bond with another ethene, and this is also going to form a bond with another ethene. So this is going to continue. So in short, the structural formula of the polyethene can be just drawn using the repeating units. So we're going to see this repeating. So to write, if you have been asked to draw the structure of polyethene, you just have to do this. Then you can put square brackets here, like brackets. Then outside you can put N, which represents the number of monomers or of repeating units that makes up this polyethene. You can't specify the number because it depends on the actual macromolecule. So the uses of polyethene are: it is used in making plastic bags. It is also used in making squeezing bottles. Next, we look at polyvinyl chloride. So for the uses, there are many. It's not just those 2 I listed. There are many. So because there are many, in an exam, if you forget, you can think of just any use of things that are made of plastic. Okay, you can say anything, maybe. Okay, it depends on the actual monomer. But even making phone pouches, you can say that, because most of them are made of plastic. So that's the insight I want to give you. Next, polyvinyl chloride, PVC. So polyvinyl chloride is made of many vinyl chloride. What is vinyl chloride? So vinyl chloride, so I said polyvinyl chloride is made of many vinyl chloride, which are of course combined. So a vinyl chloride is this. So it's just an ethene, but one hydrogen has been taken by chlorine. So when that happens, this vinyl chloride can combine with another vinyl chloride using the same process that I had explained. and we're going to have this, which is polyvinyl chloride. The uses of PVC is it is used in making PVC paints. So there are some paints which are eaten PVC paints. So those paints are made of polyvinyl chloride. It is also used in making electrical insulators, records, seat covers, raincoats, different things. Next, we look at polypropylene, which means it's made of many propene. Remember, propene is an alkene with 3 carbon atoms. So these propenes, when they combine, they form polypropylene. So this is how polypropylene is formed. So this is a propene. For those who can see how this is a propene, remember a propene is made of 3 carbon atoms. 1, 2, 3. Of course, the normal propene, we write it as carbon bonded to carbon, then we continue another carbon bonded to 3 hydrogen atoms. Okay, so this is one of those isomerism kind of arrangement where the carbon has been written here, but it is propene because it is made of 3 hydrogen atoms and 3 carbon atoms and 6 hydrogen atoms. So this propene, when they combine in the same way as I had explained, they form polypropylene. The uses of polypropylene include making pipes and packaging. So next we look at a compound called PTFE, polytetrafluoroethene. So it is made of many TFEs. TFEs are tetrafluoroethene. So for you to draw this compound, you need first to understand the meaning of tetrafluoroethene. So we are going to use what we learned in naming organic compounds. So we can start with the last word, which is ethene. So this ethene shows that the longest chain of carbon atoms is just like that of ethene, which is 2. So it has 2 carbon atoms. And since it is ethene, not ethane, means that there is a double bond between the carbon atoms. Other than that, there is this fluoro. So fluoro shows that we have fluorine atoms somewhere. So how many of these fluorine atoms? We have this tetra. So tetra means 4, just like the way tri means 3. Okay, so because of that, we're going to have 4 fluorine atoms surrounding the carbon atoms. So to draw this, first you draw 2 carbon atoms, you draw a double bond between them. After that, you draw the 4 fluorine atoms around the carbon atoms. Then after that, if the carbon atoms don't have a maximum of 4 bonds, then you can add hydrogens. So in short, this is what I was trying to describe: 2 carbon atoms, a double bond, then 4 fluorine atoms. With that, you can see that carbon has 4 bonds and this carbon has 4 bonds. So this, when it reacts with itself, it will form this. And if there are many, they'll keep on forming. So this is the repeating unit of PTFE. Uses of PTFE include insulation and rubbers. So this marks the end of this part of this subtopic. So in the next video, we're going to take a look at the last part of polymers and we'll conclude organic chemistry. Happy solving!